Good morning. I wanted to give you a little bit of a hint on how to handle Project 20, the last project with new material. First of all, at the top of the course in Noodle, you'll find a link to the student survey, student evaluations, and I would like you to complete the student evaluations. That's worth 5 points of the 20 points for this project. And when you do the comments or get to the comments section, I would like you to tell me what are the 3 best things you liked about the course and what are any things that you think I could do to improve the course. These student evaluations are for my benefit and for the students that take this course with me next year's benefit. So please give me constructive criticism there. I don't have access to these until after your final grades are submitted, so they will not help or hurt your final grade. So please be honest. I really want to hear from you. Okay, so now we will go to Project 20. And the link to the video will be here once I finish recording it and editing it. If you go into the quiz, set up as a quiz with untimed, the first question asks you if you did your student evaluations. And again, here are the 2 questions I want you to answer in the comment section. Once you have completed the student evaluations and not before, choose that you have completed the student evaluations, and you may check your answer. And I guess I got to change the settings so you'll see the points, but if you've completed it, you'll get the 5 points. Next page is an essay question essentially, and you've got a Mathematica notebook here. So there are 2 ways you can open that Mathematica notebook. If you click on the link, you see all this gobbledygook. I don't know if you all remember this in the browser. And if you just do Control A and type Control C to copy everything here. And then I'm just going to paste all of that information in there, and I get this warning message, and I'm going to say yes. And here is what I end up with. Here is the Mathematica project that you are going to work on. And it's using the RSA algorithm. You can see I've got some pretty big numbers here, so you would not want to do this on your calculator. MA is Alice's modulus, MB is Bob's modulus, and there are their public exponents here, EA and EB. And I gave you PB and QB. Those are the prime factors of Bob's modulus, and you'll see why you need those momentarily. And I've got an encrypted message here, Y and tau. So Y is the encrypted message, tau is the encrypted signature. And your goal is to figure out what the message is. So before we start, we've got to load all of these values into memory. And we're going to do that by executing this cell. Since we have semicolons at the end of the lines, you're not actually going to see anything happen. But when I execute this cell, so click anywhere in the cell and execute, then that will load all of those variables into memory. So you do not need to copy and paste any of these long digit numbers or retype them, and I do not want to see you do that. I don't want to see any of these numbers down below. Use the variables. Okay, so step 1 would be to find Bob's private key, DB. So DB, we all know, is the inverse of his public key, mod phi of m, his mod. Okay, so in an ideal world, this is going to work for us. Let's see what happens. Okay, so first of all, you notice that this bracket here is much darker. What that tells me is Mathematica is thinking. And I look up at the top here in my untitled because I haven't saved it, and it's running. So we could wait for a while and see if Mathematica successfully will calculate that inverse. I waited for a while yesterday, and I finally gave up. So if you give Mathematica a problem too big to deal with, and you've got this, or if you accidentally write an infinite loop, here's how you get out of that. You go to the evaluation menu, and then you quit kernel local. So the kernel is basically everything that's gotten loaded into RAM. So I'm going to quit the kernel local. Do I really want to quit? Yes, because that's going to erase everything in RAM. And then you got to start the kernel back, or basically the brain shut off. So we have to start it back. So anytime Mathematica is doing something that's taking too long or that you don't want it to do, then that's how you handle that. Okay, so I loaded all these variables into memory, and now I've quit my kernel and started again, so they're not in memory anymore. I got to click back here and load them again. And then I want to show you how are we going to fix this problem. Okay, so here's the deal. The m's and the e's are public exponents, and typically the primes are very large primes, and the m's in the RSA algorithm are always the product of two primes. In this case, my MA is the product of two 40-digit prime numbers, and my MB is the product of two 40-digit prime numbers, and you see the result there. Okay. The factorization of those we kept private. We don't publicize those. So Bob knows his P and his Q, but nobody else does. And if I wanted to try to factor those integers, if I do factor integer on MA, say, to see if I can figure out Alice's primes, I'm going to have the same issue with Mathematica logging up. Okay, but Bob knows his P and his Q, and then he can calculate phi of the mod, because we know that when we have a product of two primes, phi of that is just the first prime minus 1 times the second prime minus 1, and that will get us the inverse of dB. Okay? If you put a semicolon at the end of that line, and that will give us the inverse of EB, which is dB. Okay? So I'm finding the inverse, and I'm storing it in the variable dB. If you want to see what the value is, then you can execute that cell with no semicolon at the end of the line. If you put a semicolon at the end of the line, then it will execute, load the value of dB into memory, and we won't see it. And there I've executed. Okay, so you know the formulas to find x and sigma using Bob's private key with much smaller numbers. You're going to have to be able to do that on the test, so I will let you do that. Step 3 asks you to decrypt the message x using base 26 encoding. Hint, see the solutions for Project 19 to help decoding x. Okay, so I gave you the code if we had a base 26 encoded 7-letter word, exactly what you needed to do to take that big number, the base 10 value of the base 26 encoding, and translate back to the word. So you can use that code and modify it. And in this case, I've told you that there are 29 letters instead of 7 letters. So you just need to modify that code. Big hint, I gave it to you. And then you're going to type the decrypted message down here. This is just a text box, so you're just going to type the message, whatever it is. I'm sure it's something fun because I made it up. But anyway, you're going to type the message there. And then the last thing that you need to do is verify the signature of the message. So again, you know the formula for that, right? When we calculate sigma, it's raising x to Alice's d power mod MA, Alice's mod. So if we're decrypting it, we expect sigma to the e power mod m, and those are Alice's values again, to give us the x back, and that will be your verification. Okay, I hope that helps, and have a great day.